Welcome to Chapter 15. Chapters 15, 16, and 17 are the last unit in our semester, and they're all about oscillations and waves. So in this chapter, we will learn about simple harmonic motion. So by the end of this chapter, you will be able to define the terms period and frequency. You will be able to list the characteristics of simple harmonic motion. You will explain the concept of phase shift. You will be able to write the equations of motion for the system of a mass and spring undergoing simple harmonic motion. You will be able to describe the motion of a mass oscillating on a vertical spring. You will be able to describe the energy conservation of the system of a mass and a spring. You will be able to explain the concepts of stable and unstable equilibrium points. You will be able to describe how the sine and cosine functions relate to the concepts of circular motion. You will be able to describe the connection between simple harmonic motion and circular motion. So they are different, but mathematically the same. So an object going around a circle, uniform circular motion, and an object going and oscillating up and down in a spring, it's a different motion. One of them is just going up and down, the other one is going in a circle, but both of them could be described in terms of sines and cosines. So mathematically, they're equivalent. So we'll see how that works. You will be able to state the forces that act on a simple pendulum. You will determine the angular frequency, the period of and the period of a simple pendulum in terms of the length of the pendulum and the acceleration due to gravity. There is a very simple relationship that we will learn about. You will be able to define the period for a physical pendulum. So what if we have something that's an extended body where the moment of inertia is now involved? So we'll learn about those. It's called the physical pendulum. You will be able to describe the motion of damped harmonic motion. You will be able to write the equations of motion for a damped harmonic oscillators. Okay. There will be some friction. We'll be able to deal with that. You will describe the motion of a driven or forced damped harmonic motion. Okay. You will be able to write the equations of motion for a forced and damped harmonic motion. You will define what forced oscillations are. You will be able to list the equations of motion associated with forced oscillations. You will be able to explain the concepts of resonance and its impact on the amplitude of an oscillator. And finally, you will be able to list the characteristics of a system as oscillating in resonance. And that should conclude our chapter 15.